Now we will obtain volumes by cylindrical cells and apply this method if cross section is not possible, integration is difficult, or asked to solve the problem by cylindrical shell method or cylindrical cells. We have y equals to fx, a function, and a region R enclosed between a and b and x-axis, and a revolve about y-axis. Then we obtain such type of cylinders. So we can see here different right circular cylinders we will obtain after revolving this function y equals to fx around y-axis. And right circular cylinder, as we know, if the axis forms a right angle with bases like this one, which are exactly each other on right angles, then cylinder is known as right circular cylinder. If bases are not same but sideways and axis does not produce right angle to the basis, then it is known as oblique cylinder. Here we will discuss right circular cylinders. Bases are exactly at right angle. These are bases and which are exactly on right angles. Now, a cylindrical cell is a solid which is enclosed by two concentric right circular cylinders. Now, if we have two concentric right circular cylinders of radius, this is R1 radius and this is R2, and height is h, this height, then the volume V of cylindrical cell with inner radius R1, this is R1, and outer radius R2 and height h is V, this is volume, equals to area of cross section into height. So area of cross section will be pi r2 square minus pi r1 square, pi r2 square minus pi r1 square into height, and this is the volume. So this equals to pi r2 square minus r1 square into height. So this gives us pi r1 plus r2, r2 plus r1, r2 minus r1 into height. And after multiplying by 2 and dividing by 2, we will obtain 2 pi r1 plus r2 upon 2, r2 minus r1 into height. This r1 plus r2 upon 2 is known as average radius. This is the average radius of this one, of the shell. And this r2 minus r1, here r2 minus r1 will gives us this portion. This is known as thickness of the shell. This is known as thickness. And this is r2 minus r1 will be this one. Therefore, We can say volume V is 2 pi into average radius, this one, into height, this one, into thickness, this one, R2 minus R1 thickness, H height, average radius. Now we have a problem. Here function y equals to fx is continuous and non-negative function in the interval AB, and let R be the region bounded above by this function y equals to fx and below by this x-axis and lines A and B. Then volume of the solid of revolution S that generated by revolving the rectangle R about the y-axis. This is the problem. Now if we divide the interval AB into n sub-intervals and divide the region R into n strips like this one. R1, this is R2 and Rn, and into n strips and revolve about y-axis. Then we will obtain different right circular cylinders. Like in this one. And the region R revolved about y-axis. This region R revolved about y-axis. These strips generate tube-like solids in this way. This is S1, this is S2 and Sn. In this way, we will obtain Sn. Therefore, the volume of the solid is adding the volumes of the tubes. Therefore, volume of the solid after adding volumes of the tubes, that is volume of S1 plus volume of S2 and up to volume of Sn. Now we can say the tubes will have curved upper surface like in this way. So there will be no simple formula for their volumes. Now if strips are thin, we can approximate. If strips are thin, we can approximate each strip by rectangle, right this way. So generally, if we have kth strip and region R key and thickness x key minus 1 and x key. So we can take here rectangle of approximate the kth strip. For kth strip, region R key, and this is the thickness x key minus 1. We obtain cylindrical cell by the rectangle revolving after revolving around y-axis. Now, if we have when these rectangles revolved about y-axis, like in this way, we will obtain like this figure. If these rectangles revolved about y-axis, generates cylindrical cells whose volumes nearly approximate the volumes of tube generated by original strips, and add these volumes. Let kth strips extends from let kth strip, as we have seen here, this is kth strip. We can see here R key extends from this one x key minus 1 to x key. And width of the strip delta x key equals to this minus this one. X key minus x key minus 1. Now we consider x key star be the midpoint of the interval and if we construct a rectangle of height fx key star and revolving the rectangle about y-axis, we get cylindrical cell of average radius x key star, height fx key star, and thickness this delta x key, like this way. So this is delta x key, this is thickness. fx key will be this one, rectangle height, and let this point, which is x key, this point let x key minus 1, and this point mid x key star for mid point. Therefore, we have delta x key is the thickness which is x key minus 1. This is, and midpoint x key star. Let us consider. Therefore, volume V equals to 2 pi average radius into height into thickness. Now, volume Vk, we can say volume Vk of the cylindrical cell, or we can say volume Vk of kth cylindrical cell is Vk equals to 2 pi this x key star this is average radius and fx key height. This is, we can say, height. This is height. And delta x key, this is the thickness. Now, adding these volumes of the cylindrical cells, we obtain Riemann sum like V equals to sum k equals to 1 to n 2 pi x key star, as we have average radius, fx key star as we have height, delta x key we have thickness after summation taking k equals to 1 to n. And now if n increases, n goes to infinity, and assuming thickness is negligible, therefore after taking limit thickness is negligible, so we can take x key, this thickness delta x key tending to 0. So volume V equals to limit thickness delta x key tending to 0. So we can consider here maximum of delta x key tending to 0. Maximum thickness delta x key if we assume, and which is negligible, so we can say this tends to 0, and this summation k equals to 1 to n 2 pi xk star, this fxk star height into thickness of this is thickness. So this summation converts integral because we have divided into n thickness. So integral a lower limit b. This gives us 2 pi x fx into dx. This will be the volume of cylindrical shell. Now we have some formula. So here volume of cylindrical cell, we can say this equals to limit a to b 2 pi shell radius shell height into dx. Shell radius, average shell radius, fx shell height into dx. So this is the formula basic revolving around y-axis. Thank you.